This is my Snowball Crossbow. It's not as simple as just putting a snowball on a crossbow though, and you'll see why in a bit. Recently, a significant amount of snow has hit the area, and I thought what better way to leverage that than to make a snowball crossbow. This is week 4 of doing a project a week until I graduate, so that I can get the most cracked portfolio. I started by modeling the crossbow in CAD, and this is what I ended up with. There's 2 big challenges I have to tackle. The first one is how do I store energy, and the second one is how do I release that energy. Let's start with the second challenge. How do I release the energy? I do that using a latch mechanism, and that mechanism actually took quite a few tries to design. I don't like how it wobbles so much, so I'm gonna do this but over here. And I also had to take a chunk out here because if I mount this screw to this plate, it needs to be able to rotate. The trigger is just pretty much a lever that kind of pushes and pulls the second part of the latch mechanism, which moves up and down linearly because the 2 screws there pin it in place. So it is free to move up and down. The spring on the back allows everything to move back down and for the trigger to reset. This trigger actually isn't that optimized though. Let me take you into MS Paint and show you why. So the trigger kind of acts like a lever, where if I push here, then this is inclined to move down because there's a pivot point here. The big issue is that I lose a lot of force because these distances are the same. This distance at the top was shorter, say half as long, then me pushing this way with some force, let's say 10 newtons of force, means that I would get 20 newtons of force pushing downwards. Since everything is the same length, me pushing here with 10 newtons of force means I only push down on the trigger part with 10 newtons of force. I don't get any leverage, which means it's pretty hard to pull the trigger. I eventually pay the price for this design later on. All right, let's go ahead and tackle that first problem though. How do we store energy? I'm using this material called spring steel because it acts like a spring, and I know bow arms act like a spring, I think. So I went ahead and cut some on my school's metal laser cutter. Yeah, this machine is such a cheat code. I'm gonna miss it when I graduate. After making the bow arms, I went ahead and 3D printed the body, which is printed in 2 parts and connected using a dovetail joint. Throughout this process, if anyone has any ideas on how I could do things better or faster or more optimally, I would love to hear and get some advice in the comments. Part of the reason why I'm doing this channel in the first place is to learn, so. The first part of the body is made out of plastic, but the second part of the body, that's made out of aluminum. So off to the CNC mill I went. I'm using Makera Carvera Air to machine all of these aluminum parts. The machine has a quick tool changer and an automatic probe and leveler, which is actually really useful. What's great about the machine is that it also has a 0.01 millimeter spindle runout, which means I'm able to get pretty precise cuts on a desktop CNC machine. And if you know anything about motors, these motors have closed loop steppers too, which means that you don't have to worry about things like how 3D printers have step loss sometimes. This machine knows where it's at all times. The machine also has a 4th axis module and a laser module, which is kind of crazy. So this could also be a laser cutter if I needed it to be. And yeah, it works with things like wood, brass, aluminum, and plastics too. The machine is also fully enclosed and you can use whatever CAM software you want. So it was really easy for me to get started using Fusion 360 CAM because that's what I'm used to. I didn't have to learn anything new. So yeah, if you're looking for a desktop CNC machine, you can use my code in the description to buy Carvera Air for $100 off. And even though this video is sponsored, you can look at my previous videos where I actually used this machine before I was sponsored. So I really do like using this machine. It's pretty goated. Like genuinely, this machine cuts through aluminum like butter. It's like the Bamboo Labs of CNC machines. After I CNC machined the parts out, I went ahead and post-drilled out the holes to get ready for tapping the holes. Also, while we're here, let me know if you guys would rather me like yap through the videos or if I should have more pauses and have some background music going. I'm still trying to figure that out. The back of the trigger has a slot in it for where a spring goes. I'm going to do that quickly on the manual mill because you can hear in the background I have the Carvera Air running on a different job. Now that all the parts for the trigger finished up, I went ahead and added threads to the front mounting of the crossbow. These are all the parts that we need. So we can now put everything together. So you may be wondering why there's a weird band on the 3D print, but it's because the print paused in the middle, which caused the layers to not adhere properly. So I use super glue between the layers to help hopefully make it more structurally stable. I clean it up and make it look a little better with the paint job later on. Right now I'm fiddling around with assembling the trigger, and it's kind of difficult because there's not really much access. And I need to get the spring in there, which is kind of hard to do. I eventually am able to finagle it in there though. Okay, so this is what I have so far. I put a bungee cord on here because although it makes more sense to have a rigid string, I'm physically not strong enough to pull it back if it was rigid. So I'm gonna tension this until it's tight enough for me to just about pull it back, and that's as much as we'll get. So like this can bend quite a bit, but I physically can't do it. The latch mechanism works pretty well, other than the fact that if I put it up here, the leverage means that it's really hard to press, but if I put it down here, it works just fine. So I'm gonna cut this little notch. If I put the string here, it's just impossible to pull. If I put the string or the bungee cord a level down and onto like the second notch down here, then I can just about pull the trigger. So to remedy part of the trigger issue, I go ahead and mill down the second part of the trigger. Alright, now I go through the process of sanding and painting everything, and I've actually never done this before, so. Since it's cold out, I don't know if it's a good idea to leave these parts outside for them to dry, since I think they'll freeze or something. So I went ahead and tossed it into the laser cutter because it's warm inside and it takes out all the fumes. Here's the first test with the Snowball Crossbow. This is actually before I spray painted it. I just wanted to get a shot in. And you can see how this goes. So not well. It just obliterates the snowball. Kind of expected that would happen. So I went ahead and 3D printed this little TPU thing that distributes the force from the band more. So hopefully it launches the snowball rather than exploding it. Ooh, that works. To be honest, it's not very effective, and I think part of it is because of projectile weight. I try a lot of different things with different packing densities of snowballs, but I'm not able to get it to shoot very well. Yeah. I mean, it kind of works as a snowball shotgun, if you think about it. It's still fun to play with. Even though it's not great at shooting snowballs, it can shoot other cylindrical things. So if you made it to the end of the video, thanks. Maybe subscribe and watch me shoot the most effective projectile I found, which was a duct tape roll.